Okay, so we're going to look at systems of equations, but I'm going to do systems of equations in 2 variables, not 3 variables, just to show you the technique, okay? So we've got x and a y, systems of equations, 2 variables. Right, one way of doing it is to graph. Now, if I graph the first one here by intercepts, in other words, when x equals 0, what is y? Well, if x equals 0, y is 8, okay? So let's go back and just get rid of that, that's 8. So I think that's there, okay? There's 8. How about when y equals 0? When y equals 0, can you see 2x equals 8? So x equals 4. So where's 4? That's down there, okay? Then I can just draw a straight line between them, and that's the graph there, okay? Something like that. So that is, and that was 4. So that is 2x plus y equals 8, okay? Right, let's graph y equals 2x minus 4. Now, I'm going to do this by slope-intercept. The y-intercept is negative 4. Remember this? Y equals mx plus b. So that's the y-intercept, negative 4. The slope is positive 2, so I'm going to go up 2 and over 1. So from here, I'm going to up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And if I draw a straight line, hopefully, can you see where they cross? Right there is the solution, 3, 2. In other words, x equals 3 and y equals 2. Okay, that's the answer. Great. I graphed them. Now, I'm now going to do it by elimination, the substitution method. Now, the substitution method, this one is kind of set up for the substitution method because, look, if y equals 2x minus 4, if that's what y equals, I can plug it right into here, into the first equation. In other words, 2x plus y, but y is 2x minus 4, isn't it? Okay? There we go. I replace the y with 2x minus 4. Now, 2x and 2x is 4x. Still got the minus 4, still got the 8. Add a 4 to both sides, I get 12. Divide both sides by 4, I get x equals 3 again. Okay, remember? That's what we've got for the graph. Now, what I need to do now is plug it back in to find the y. And we're already set up, because it's the substitution method, I've already got this set up for y equals. See, y equals 2x minus 4. So y equals 2x, x is 3, minus 4, 6 take away 4 is the 2, which is in the graphing solution, okay? So that's that was substitution, okay? Substitution. Substitute one equation into the other. Now, that was nice to do by substitution because I had something with a single letter, a single y, so I could do a substitution. We'll show you ones that are going to be a little bit harder if you don't just have a single letter. But now let's look at it by the elimination method. So again, I've got 2x plus y equals 8. But I'm going to rearrange this. I'm going to put the x's and the y's on the same side. I'm going to take away 2x from both sides. I'll have this. Okay, so this equation becomes that one there. If I just take away 2x from both sides, okay? In other words, I took rid of that 2x. Right, now, this is why it's the elimination method, because look, if I add these two together, 2x, negative 2x will cancel. 1y and 1y is 2y. 8 take away 4, or 8 add negative 4 is 4, so y equals 2. And again, if you look over there, that's what we've got for y. Now, I've now got to plug that back in, and you can plug it back into wherever you want to. It doesn't matter where you plug it back into, okay? Just plug it back in, and you will get x equals 3. So, now that was a fairly easy elimination one, because I didn't have to do anything. Look, a 2x and a negative 2x will cancel. Great. What if it's harder? Let's take a look at some other ones. Okay, so, again, now, I'm looking at this, and I don't think I can really do substitution here. I mean, I probably could do, but I'll show you a method of doing that. Because I don't really see a single letter. I've got 7x and 9y and negative 2x and negative 4y. There's no x equals or y equals that I can substitute. I could manipulate it, but let's do this. Okay? I can't add them together to eliminate the x's or the y's. So I'm going to look at the x's. I've got a 7x and a negative 2x. What's the lowest common multiple, or think lowest common denominators of 7 and 2? It's 14. So if I multiply the first equation by 2, I will get 14x plus 18y equals negative 30, okay? So that's my first equation multiplied by 2. If I multiply the second equation by 7, I will get negative 14x minus 28y equals 0. 7 times 0 is still 0. And again, this is why I did it. Look, the x's have cancelled. If I add these together, the x's will cancel. What's 18y? Take away 28y, that's negative 10y. What's negative 30 and 0? That's negative 30. So it looks like y equals positive 3 if you divide both sides by negative 10. Normally a good clue, if you've got a nice whole number, you've probably done it correctly. Right, if y equals 3, I've got to plug it back into y there or there. I'll do it back into this one. Let's do y equals 3 back into this one. So 7x plus 9y, remember y is 3, equals negative 15. So 7x plus 27 equals negative 15. Take away 27, you get negative 42. So x equals negative 6. Okay, so x equals negative 6. And those are your two answers. Okay? Now, what I could do is this. Now, let's go back to this. I'm going to erase all this. That's it. I would do it that way and get my two answers. But I suppose I could think about substitution if I did this. 7x plus 9y equals negative 15. Divide this equation by negative 2. Okay? Take away the 2y. Right, I can now do a substitution because I've got x equals negative 2y. I can plug it into here and get 7, negative 2y plus 9y equals negative 15. That's negative 14y plus 9y equals negative 15. So what's that? Is that negative 5y equals negative 15? So y equals 3? There you go. And of course, I'm going to get x equals negative 6 again. So I could have done that by substitution if I'd have really pushed it. I'd have preferred elimination. Now, let's take a look at this next one. This will be a horrible one to try and do a substitution method, I think. Yeah, I can't really get x equals or y equals unless I might end up with fractions. So, let's do the elimination method. Now, you can choose to do x or y, but look at this. I think I'll choose the x's because, look, 3 and 4, lowest common multiple is 12, okay? But one has to be positive, one has to be negative. So when I add them, they disappear. So what I'm going to do is I'm going to multiply the first one by negative. I don't know, I'll do it by times it by 4. Okay. Multiply by 4. I'm going to get this. 12x plus 20y equals 84. Okay? So there's the first equation multiplied by 4. Multiply the second equation by negative 3. Negative 3. So I'll get, right, times it by negative 3. I will get negative 12x, negative 18y equals, what's 3 times, what's that? Is that negative 78? Yeah, negative 78, okay? Right, that's why I did it, so they'll cancel. Can you see that's 2y, that looks like it's 6, so y must be 3, okay? Plug it back in. Doesn't matter. I think I'll go back up to the first one. Okay? So if y equals 3, I've got 3x plus 5 times 3, because 5y equals 21. So that's 15. So I take away 15 from both sides. 3x equals, what's that? 6. So x equals 2. There you go. Okay? So again, it's just knowing how to manipulate it. So you can do the elimination method. So those are systems equations in 2 variables, okay? Now, I'll just mention that when we do 3 variables, there are much easier calculator methods to do this. So I might show you this technique in 3 variables, but also calculators. Calculators can do this, all right? And we allow you to do that. You know, when we do matrices in one of these sections as well, you can use the graphing calculator if you have one, because it's easy to solve.